Welcome everybody. This is kind of a something that really wasn't scheduled or planned. I decided to offer this webinar since it is a new simulation. We haven't had a severe WES simulation for about 2 years, and thought it'd be a good opportunity to kind of see some of the details of the simulation and get some tips and an opportunity to ask some question and answer, especially for those who may have not facilitated a simulation in a while. So with that, I'll go ahead and get started. This particular WES simulation, started working on this, it seems like at the end of 2017, and then ran into some issues with getting the data trimmed down in the spring. We finally got it out, so we ended up getting it done about 4 months later than expected. But nonetheless, we shipped this out at the end of July on a Blu-ray disc and to all offices. And so there's kind of just 3 main topics that I wanted to talk about: how to prepare the simulation, some of the technical parts of it, conducting the simulation, and debriefing the simulation. With any simulation, there's a lot of different ways that you can go with it. There's a lot of different ways you can go with the simulation, but I'm going to just convey a few things that I've learned over the years that work pretty well. If you do have a question, go to the question dialog box, and I'll try to address that. So just the logistics, first of all, kind of some assumptions when you start this simulation. You need to make sure that your WES 2 Bridge workstation is properly configured, and what I mean by that is it has the correct operating system and the most recent WES 2 build installed. The training officer needs to be familiar with the resources that we have, including the simulation guide, the installation guide, the simulation guide, and the simulation answer form that the trainees will be using. In addition to setup time, which can vary, based on number 1 and number 2, the trainee needs to have a minimum of 2 hours to complete the simulation. That's for just the essential parts for kind of like a standard simulation. The training officer needs to have at least 2 to 4 hours to facilitate the simulation. Now, that doesn't mean that that's all the time it's going to take, but in working with these types of simulations, you need to allot that much time per person. Now, if you have 2 people going through it at the same time, then of course you can kind of maximize your amount of time there. But those are just some general logistic parameters. Some of the resources, of course, the facilitator's guide, which contains a description of the event, the key learning objectives, some of the details to be used in the debrief are available from our WOC Severe homepage that you can get to. And if you just boil down the essential steps to complete a simulation, there's 3 main things. Of course, each part is entails some work, but the first part is, once you've installed it, is to go through the simulation. So the student goes through the simulation, depending on the amount of time they take. They fill out a WOC Severe GSP QLCS simulation answer form, which is a Google form, and then after you do your debrief, you complete a little 1-question test item in the CLC, and that's kind of the quick and dirty 3-step process for completing it. Now, of course, it's not as easy as just logging onto the LMS and going through a module. It's just I think the value of a simulation, it is a little bit more complex. You can get a lot more out of it, so it takes more time. Anything that's worth anything is going to take a little time. So I'll just quickly kind of go through the installation tips here. They're pretty self-explanatory in the guide. If you follow them, it works. And the first thing is use the installation guide. Make sure you have the WES 2 version, at least 17.1.1. They are releasing a new version, so they're there are different steps based on the version that you have. Make sure you load the disk and load the case. Once the WES 2 Bridge dialog box comes open, it'll look like that. You'll load the case, which is WOC_Severe 18 2017 October 23rd GSP. So the screen captures in the guide are essentially duplicated here. You'll see the exact same things that I'm showing. The next step is to ensure your EDX00 is started so that the WESL2 script will work. So you make sure that EDX00 is started. Then you right-click on the case name from the available cases and click Simulate, and that starts the simulation. And that's just a Simulate button there in the upper right-hand corner for that particular case. Then we created a little macro to run the simulation, and so you'll select the WOC Severe FY18 simulation and click OK. That will set all the following details, including the right time stamp that's used in the case. We essentially have the simulation starting at 18Z and going through till 21Z. The data runs from 12Z to 0Z, and then there's the WESL2 script name, which is GSP WESL. You need to make sure that'll automatically load with the macro, but if for whatever reason it doesn't load, you'll click on the relaunch WESL. So once you hit play, at this point it'll begin the simulation. If you're following the script that we have in the guide, you'll want to allow a few minutes to allow WESL to start to display SPC mesoanalysis products and hit pause. At this point, you'll also want to make sure you open a text window in Cave so that the training will be able to issue warnings from Origin. So there's a look at the simulation control GUI. This is just a slide I put in there based on some things that Alex Zwink told me. One office had created a localization copying cron, which was screwing up some of the localization linking. So don't do that, bottom line, because it makes permissions too restrictive. But he kind of cringed when he heard I was going to put this on here, but it has come up, and we had an office have some issues with that. But main thing is don't create one. Don't use cron jobs. Okay, so that's essentially the installation part, which is fairly straightforward. You need to have at least 24 gigabytes of disk space on your box. Once everything's loaded and you start the simulation, you have paused it. This kind of describes essentially this particular case, and I broke the simulation into 3 parts, the first part being threat assessment and DSS. I have it starting at 18Z, so essentially you're looking at the entire domain of the data set at 18Z to do a threat assessment. And we'll talk about that. Part 2 essentially captures the first phase of this mature QLCS, including the multiple tornado reports, damaging wind, all the way from just a little southwest of Spartanburg and east of Greenville, all the way up through just west of Statesville. And so part 2 in simulation modes is essentially 80% of the simulation. The main benefits are result of part 1 and part 2. Part 1 being essentially doing the threat assessment and the hazard potential for tornado, wind, and hail. So those are the most important parts. There's also a part 3. There's multiple sections within part 2. I'll talk about which ones I think are important to go through. Part 3 is the evolution of the QLCS, where it occludes and some of the circulations pull back in the stratiform precip, and it runs from 1930 to 2030. It's optional, and I don't have a lot of details in the guide in terms of specific lat longs of signatures and so forth, but the last TDS essentially occurs about 1936Z, and then after that point it's just a lot of sporadic wind as the QLCS becomes a little more fragmented in terms of the overall structure. There's individual bowing structures further east, but I'd leave that as an optional part. Part 2 is really the most important part of the of the simulation. And then in details for part 1, these are the objectives. Of course, you're going to want to analyze the environmental data using a lot of the data sets. This is the first simulation that we've included SPC meso products, so the way we do it with our simulations here is we have that on the top monitor, and that is really important for that first part. Once you get into the event by, say, 19Z, I don't think that is quite as important, but certainly at 18Z you need to be looking at the meso, and there's instructions for looking at the meso page, looking at certain, some of the parameters to come up with a categorical hazard assessment for the different threats. There's also the QLCS tornado/wind environmental bundle that's available, and I'll talk more about that. The main thing that you do in part 1 is the student will be writing a meso AFD and describing the ingredients and what they expect, and then on the online form be able to do the hazard assessment for hail damaging winds and tornadoes. And then there's 2 DSS injects that they'll have to answer on the form based on the timing, so that you can use some of the model data on that, including some of the CAMS output. And then these are some of the main competencies: being able to recognize and enhance the risk of damaging wind and tornadoes from QLCS, being able to note the orientation of strong 0 to 3 kilometer line normal bulk shear vector, which is conducive for mesovortex intensification and development, and a lot of these environmental parameters as well. They should be able to note those. There's a marginal risk of hail. Should be able to recognize that, so that could eliminate that particular tag in their warnings. They should be able to evaluate the timing of the threats for DSS impact. So the time to complete part 1 is from testing and experience will run about 45 minutes to an hour and a half, depending on how detailed they want to get into the analysis, and they certainly don't have to look at, like, for example, every forecast down there, every model. That is something, you know, if you look at 2 or 3 runs, you look at the RAP and the NAM for this case, and certainly from the HRF, you're going to see, you know, you're going to quickly determine that this is a strongly forced high shear low cape event, and even the cape itself. For a lot of East Coast storms in the fall season, it's still pretty impressive. Like I said, no ML SIN, sufficient ML cape to over 1,500, effective SRH of 567. So very strongly forced event, very dynamic system. But again, part 1, do an AFD. Part 2 is where it really gets into more storm structure and interpretation. So we call this part storm scale intensification to TDS development, and it runs. You can run it from 18Z to 1939, and the real action starts about 1840. But there's certain signatures that start showing up as early as 1815, and one of the parts you should use the 3 ingredients methodology to identify potential areas of mesovortex development intensification, and you can start doing that right away after you do your threat assessment in part 1. You can start the simulation, or unpause it and start it up, and you can start seeing the data coming in, and start looking at and start doing part A. So anyway, I had a question from Pete Wolf. In starting a simulation, will the student know it will be a QLCS? And the fact that they're doing a simulation usually hints it will be a bad event. How to keep student honest at the start? Okay, that's a good question. The student will not know that it's a QLCS, although if you've got someone in WOC severe, we've been talking about shipping out a QLCS simulation for a long time, so I think they know it. They're not going to know the specific time when the severe threats will be occurring. So I think the challenge will be and preparing them for sitting down and say, okay, you don't have to worry about a forecast of anticipated convective mode. This is a QLCS. Your job is to apply the 3 ingredients to identify potential areas and to support warning decisions. And you also have a lot of multi-sensor products, including Lightning, GOES, Data, MRMS products, and so that really makes this a more robust simulation than we've ever had. A lot of different data sets to use to be able to identify storm structure and interpretation. So that gets into Part C, and Part C is the multi-sensor part using the MRMS products, and this section is designed a little differently in that with the 3 ingredients, the main task is to identify areas of where you expect mesovortices to develop and issue a warning. With Part C, I think the benefits are looking at all the products to determine changes in strengths of updraft signatures. So it really works best in like maybe a different type of deal where you're not issuing warnings. So that's how I would use Part C. And then Part D is just using base data to track TDSs. There's about 3 TDSs that are clearly evident throughout the simulation. So you can use the simulation for evaluating TDS characteristics so that you can put that information in warning products and decision support. So here are the competencies to evaluate for this section. Again, it's a lot of storm structure, evaluating or identifying areas of potential mesovortex development intensification. If you can translate the skill into good warning decision making and polygon placement to maximize lead time. So if you can do one well, the thing to evaluate is how well that they can take that, knowing the conceptual model and identifying those regions to making good warning decisions. And so that's sometimes the leap from 1 to 2 is there's a little bit of a gap there. And then the number 3 is the multi-sensor product integration and how to use that for recognition of updraft signature changes and storm motion trends. One of the things we found in this case is that the lightning jump was very evident prior to the bowing of the initial QLCS, and so it's good to integrate all these products in. You can and looking at the height of the reflectivity above the -10. There's a lot of nice changes in structure. You have to use the 9 panel to be able to get all those, but you can really learn a lot about overall storm morphology by doing that, going through that section. And then the last one is, again, how well you can quickly identify TDS characteristics and use that in warning decisions. So the time to complete this section is a huge variable, anywhere from 1 to 4 hours, depending on which parts that you want to go through. Just some tips on how to run through it. Of course, it is the QLCS methodology, so you might want to review the WOC Severe QLCS 3 ingredients methodology, which is on the web, and review that so that when they do get into that, they know what to be looking for. The 3 ingredients: the orientation of the line normal shear in the slightly cold pool shear balance region, and where you have a surge. So the juxtapositions of those 3 criteria is important for identifying the areas. And in this particular event, as in a lot of QLCSs, the radar rotational velocity, the VR shear, will not provide much lead time on the QLCS tornado information, since it's a classic bottom-up formation. It will give you an intensity. You can certainly see some intensity changes, but not much lead time. So that's why you have to be more anticipatory in terms of identifying the areas where they will where they can develop and intensify. The favorable environment does allow you to be a little more proactive in the warning decision and practice that. It's not going to obviously come automatically. I think it's going to take some practice and getting comfortable with taking, recognizing those areas. If you've got warning forecasters who are waiting for a particular signature or VR strength, it's not going to work with QLCS. The 3 ingredients method really teaches you to look for the features when assessing QLCS tornado potential, like the balance or slightly shear dominant portion of the line, where the 0 to 3 line normal bulk shear is greater than or equal to 30 knots, and then looking at the rear inflow jet or enhanced outflow causing the surge in the bow and the line, and as well as the other features like identifying the updraft downdraft convergence zone, looking at entry inflection points, descending RIGs, reflectivity drops, line breaks, front reflectivity nubs, entry points are really, so a lot of things are important when you're using this methodology. When you evaluate the trainee on this, evaluate how well they can predict likely outcomes. And really even that, you can have really experienced forecasters. That's not enough for good decision making. You have to be able to learn from experience and pay very close attention and really aggressively drawing the lessons from the experiences. So that's why these cases are good, because when they have an event, when in your CWA, they'll be able to translate that and see patterns and causes and effects, and then you start thinking ahead with insight. That's the key to decision making, good decision making anyway. Had another question from Brett Williams about lightning jumps for the win. That's good. So Brett was the one who did the training on that. So yes, this is a good application of that in a simulation. So anyway, back to the this part of the simulation. This is just a screen capture at 1809. We do provide some screen captures of some recommended warnings for this particular case, and the first one you can certainly lay out as early as 1809 based on the configuration and the tight reflectivity gradient and some mid-level convergence, which develops just to the south of the apex of the bow. And then you get the things that you can look at again before you start issuing warnings is the QLCS tornado wind environment bundle and using those line normal bulk shear arrows. And thanks to Dale Morris, he loaded these NSEA, Near Storm Environmental Application Digital Cursor Readout bundles. So there's a bunch of these bundles in here. I like to look at the shear parameters and display the line normal bulk shear arrows from the HER, and they give you kind of like a window of where you're going to have that line normal shear greater than or equal to 30 knots, and where it doesn't display within these two arrows that you don't have it. Fortunately, in this case, it's right in through here, and you've got at least 30 knots. In fact, you've got, if you kind of have to do this technique right, you have to draw an imaginary, you kind of have to do a lay out the draft downdraft convergence zone, and I didn't do a very good job of that, but then draw line normal vectors to all these, and that's a terrible color. Get a different color. So do something like that, and you do these line normal to that. So anywhere that line normal vector is between the two arrows from that, then you're going to have at least greater than or equal to 30 knots. That's the application of the principle. And so this is another example from a Google Docs. I'll share the Google Docs that has a description of how to use this particular tool. But anyway, it's in this case, and Dale Morris put the procedures in there so you can use the near storm environment algorithm, and also you can do sampling as well. So you can sample the line normal shear vector right from the right on the cave, which is kind of cool. So practice tornado issuance. We went through this case over and over again, had a number of different Experienced warning forecasters look at this and evaluate when they would issue a warning based on the data, and this window is kind of the window of opportunity. At John Gagan, who's a SU up in Milwaukee, and also Jason Shaman at Springfield, who are kind of the authors of the 3 ingredients method, along with the late Ron Prespolinski. But they looked at this and they said there's some really strong nudgers to increase confidence that you can issue a proactive tornado warning. And the key area is right along where the UDCZ starts curling back, and where this occurs, you're getting the downward tilting of the vorticity lines that get stretched up by a surge in the updraft, and that causes the development of the mesovortex right in this area here that I've kind of circled. But when you go through this case, you'll be able to really pick up on this. This front entry point is really key. There's also these light showers out ahead of the line, which is another indication. When you get this, it may be an indication of very strong upward motion, and it's almost these get tilted up or get ingested into the line itself, and tend to enhance the vortex development as well. So this is at 1843. Again, the real action starts about 1830, but if you have your forecasters go through this, you can really teach them or encourage them to start thinking tornado warning as early as 1830, and by 1846 they should be ready to pull the trigger. And then by I want to say 1846 is in sales data, so you get scanned every 2 minutes. So you can really be proactive. By this time, the tornado occurs in 6 minutes, so you've got a 6-minute lead time if you wait this long. We kind of encourage you to issue as early as 1841, and again, it's right in this region right here. But if you want to get real familiar with the data, what you can do is you can load it right up on your WES machine. You can also just get the GR2 data as well and play it. I did both, but at this point, again, try to get them to look at tilts aloft as well. There's a pretty good signature initially with the lightning jump and the increase in the updraft surge about 30 minutes prior to this, but by 1848 you really need to be pulling the trigger, and by this time it's tornado time, 1851. So it's a really good example of rapid tornado genesis with a QLCS. It's a great case for that. And then as you move on in past 19Z, you get multiple TDSs, multiple mesovortices, all as the updraft downdraft convergence zone gets contorted back into this region of the storm. And nothing really forms down here on the southern part because, see, that's that's cold pool dominated. Okay, the multi-sensor 9-panel section is very tedious. It's not recommended for a 1-hour warning simulation. Consider doing this as a part of MRMS Lightning Goes Our concept refresher training exercise, just because it's very tedious. But if you do go through that, the idea is your forecaster will be able to kind of rate which of the products are the most beneficial for each 15-minute time frame. And there's some good opportunities to learn about storm structure by going through the multi-sensor. But if you want to do that, you'd have to stop it and then go back and start it up again at 1800. For the last section, consider doing a separate skill practice for the TDS recognition. Like I said, there's 3 TDSs in there, and they're good for, if you want to track TDS signatures. Other things that are useful, consider using the Gruden Film Study approach with this case. In other words, as you're going through the simulation, you may want to pause it and ask the trainee what are they seeing, as opposed to just having them go through and issue blanket warnings, because I think you can get more to their decision-making, analytical reasoning, as opposed to just looking at their answers. So you might consider that approach. You can also have two people going through the sim at the same time, sometimes at even different skill levels to provide benefits. They can provide answers together, so it's almost like a team approach. You get one forecaster doing mesoanalysis and another doing storm interpretation and warning. So that could work pretty well with this case as well. One person could do the whole thing. It's not as rapid fire as, say, like we had that super derecho event in Southwest Missouri that we put a simulation in. That one you certainly couldn't do that on your own. There's too many warnings, but for this one you could do, one person could do the whole thing. And then the key thing with this is there's always a gap between intention and action. People have the best intentions to change their behavior to start using a certain methodology, but what happens is that we unconsciously go back to our old methods. So with experienced forecasters, you might want to have things like commitment devices, which, in other words, things pop up that cause you to look at certain products. So you might want to build in some procedures to kind of forces you to look at certain things and get people out of their comfort zone. We do that a lot in our RAC workshops to help with again, creating that intentional mindset to change behavior. Otherwise, it's real easy to just kind of go back to the way you've been doing things. In debriefing, again, the thing to do is assess the trainee's ability to perform the objectives in the simulation guide at acceptable levels of competency. I put those in quotes because it's going to be different for different people. For someone who's never worked a QLCS event, it's going to be tough to be really proactive because they may not seen these things a lot, and they're very. So I'm going to provide a student assessment form similar to what we use in the radar in the radar application course, where you have the simulation performance objectives on the left, and then you have instructor comments, and that's a way to kind of assess how well they're proficient at the basic things. It's not real detailed, but it can kind of help in the debrief. After they've gone through it, you can go over how well they did these things. So you can replay the learning performance outcomes, such as their hazard assessment. Did they not pick up on STP, getting over 2, or Shear being over 2, things like that? Did they look at the cans? Did they properly evaluate the 3 ingredients? So these are some of the things. Plus, there's many more discoverable things that you can include in a debrief. You can add a learning objective. In other words, how well they integrated the GOES-R data to the pre-storm environment. Things like that, and handling workload for multiple warnings. So there's a lot of different things that you can use in the debrief. The main thing with the debrief, we always follow the 3 R's, and that's recollection, where you play back the data, compare the signatures with the damage and impacts. Then you reflect. You have a little session where you respond and react in dialogue. You don't want to just immediately start talking to them, but listen a little bit, ask them lots of questions at this point. Then the third part is reviewing to uncover the motives behind the actions, behaviors, and decisions. That's where you go into the answer guide and ask them, what did you I see where you didn't use this particular product. Why is that the case? Do you not understand it? Why to use it, and so forth. So this is just kind of a three-way process to get the best out of a debrief, to kind of learn and go forward. And the key after a debrief, obviously, be positive, outline path for potential performance improvement. If they do have some gaps in their knowledge of conceptual models, then that might be a good opportunity to talk about taking some associated training. Repeat the application. It's always good with these types of simulations to do them multiple times. Every time I've looked at this case 100 times now, every time I play it back I see something different that I've missed before, and I could say that about just about every weather event. If you study something long enough, you'll always find something you missed that might be interesting and useful in a future situation. Learn from experts. There's certainly some expertise that's built up in the field from people who are really good at QLCS warnings. I know some of them are at St. Louis, Springfield, and various places that really have had lots of experience and has some good techniques and methodologies. You can learn a lot from those people, and you might even have some in your office. You're really good at the techniques and understand the processes. It's different, as you know, than supercell tornadoes, for example, and there's some expertise developed there, so encourage them to learn from that and use them as you facilitate these simulations. You might want to have a little seminar after a simulation experience where you do go over the science. Fill out an evaluation to improve the training. Let us know if will meet your needs and how we can improve it. It's every time we do one of these, it seems like we learn how to do it better next time. I'm including a bunch of QLCS tornado and near storm environment application references. There's a Google Docs that's titled NSCA Digital Cursor Readout 0 to 3 bulk shear arrows, and lots of links on the page to VLab, and also some good YouTube videos. But this are some really good resources for using the 3 ingredients methodology. And if you have any questions on the technical part of the WES 2 bridge, Alex Swink is leaving us, so I didn't put his name up, but Del Morris is our WES 2 guru, and you can contact him, and he can has a way they can log into your WES box and help troubleshoot. And so he's really good, and also there's my number as well. So we're glad to help you out. So this will be, make this a good experience, and we'll really look forward to your feedback on how this is working for you. So with that, does anybody have any questions? I didn't see any more submitted, but I'll wait a little bit. All right. Well, I appreciate your time today. If you have anything that come up as you go into it, let me know, and I'll look forward to helping you out. Otherwise, I appreciate your attendance today, and good luck with your simulations. Let's see. There was a question from, I'm sorry, Brian Curran had his hand up. And Dan Bumgar says, excellent, thank you, we'll hit the ground running. Cynthia Palmer says, can you please go back a slide? So I'll do that. Okay, there you go. For Cynthia. I wish I could hear you guys. Really don't like this audio. Chad has got one. Yes, Chad. Will a copy of the slide be available? Yes. It'll be a reference to the Gruden film methodology. The reference to that, actually, you have to just kind of watch the guy. He used to be a commentator on ESPN, but the way he does it is he studies a lot of film, and I don't know if I've got a reference for that, but I've heard from some other SUs and forecasters that they like to use that technique. It's almost a Socratic method of question and answering, but it's kind of like, you put someone in a situation, say, tell me what you see, and what do you as opposed to just having them go through and answer basic questions answer. But can we add our origin localization? Yes, I think you can. It has the GSP localization on there, plus all the procedures we bundled up from rack and walk. I created about 6 procedures just for the storm interpretation stuff and the 3 ingredients, and then Dale came along and installed all the NSCA digital cursor readout things. So I mean, if you use those, they're fantastic for shear and buoyancy. Plus, I think it's some guy named Christopher Stump created those from Huntsville. It's a fantastic application. So I would really encourage you to use those if you can. They're installed with the case. So. All right. Well, thanks everybody. If you've got any more questions, let me know, and I will also send you the little link to the eval form that you can use if you want a little hard copy to grade it. Otherwise, use the online form. And again, they don't have to fill out everything in the online form. If you only do part 1 and 2 and you skip the MRMS stuff, that's okay. Just skip through that and hit submit. And don't worry about having to do every single part. That's one thing I learned from the last simulation, is that where I had I had decision points set for, and you had to answer every single one. I'd learned this time to make it a little more flexible. So hopefully that'll work better. All right, have a good one, everybody. Talk to you later.